Hello everyone, hope all of you are very well. Today we will discuss about the Fourier series. Okay, so this is our chapter 2, Fourier series and transforms. Okay, so at first we will see the definition of Fourier series, that is definition of Fourier series. Okay, let the function f of x satisfy the following conditions, which are f of x is defined in the interval minus L to L, f of x and f prime of x, that is the first derivative, are sectionally continuous and C f of x plus twice L equals f of x, that is f of x is periodic. With period twice L. Okay, then at every point of continuity we have, or we get, f of x in the form f of x equals n0 by 2 plus summation n cos n by x by L plus bn sin n by x by L, where n goes from 1 to infinity. Okay, so this is the general form of the Fourier series of the function f of x. That is, we may call the Fourier series is a series of representing function in the term of sine or cosine terms. Okay, basically by this Fourier series we express each and every function which are expressible in the, as a sum of sine and cosine functions. Okay, so here the terms a0, an and bn, these are called the coefficient of Fourier series. Okay, so we can write where a0 means 1 by L minus L to L f of x dx, and an equals 1 by L minus L to L f of x cos n by x by L dx, and also bn equals 1 by L minus L to L f of x sine n pi x by L dx. Okay, so this is equation 2, this is equation 3, and this is equation 4. Okay, now we write the equation 1 with coefficients 2, 3 and 4 is called the Fourier series of f of x. Okay, so you may find different definitions in different type of books, but our basic term is this part. F of x equals a0 by 2 plus sum over n equals 1 to infinity n cos n pi x by L plus bn sin n pi x by L. Okay, so if we are told to find the Fourier series of any function, we will have to find these terms a0, an and bn only. Okay, the interval of x, or the limit of x, that is minus L to L, will also be given in the question. Okay, so basically these are three definite integral we will have to evaluate to find the Fourier series of any function. Okay, so now we will illustrate this topic with an example. Okay, now see, okay, example 1. Example 1, find the Fourier series of f of x equals e to the power x from minus pi to pi. Okay, solution. So given f of x equals e to the power x and minus pi to pi, so with L equals pi, if we compare this part with the definition, so our L will be pi, the Fourier series of e to the power x, that is of e to the power x, is we can write, that is f of x equals a0 by 2 plus summation n cos n pi x by pi instead of L plus bn sin n pi x by L. Okay, n equals 1 to infinity. Okay, this is equation 1. Okay, so now our main task is to find the coefficients a0, an and bn. So now write where a0 equals 1 by L, that is 1 by pi, from minus pi to pi, f of x, that would be to the power x dx. Okay, so if we integrate, this will become 1 by pi, as we know. Integration of e to the power x equals e to the power x. Okay, a lovely function. Okay, and from this we will get to the power pi to the power minus pi. Okay, so now we will find the value of an, that is an equals 1 by pi minus pi to pi. F of x, that is e to the power x, and it will be cos n pi x by pi instead of L, it is dx. So it will give 1 by pi minus pi to pi e to the power x cos nx, as pi cancels each other. Okay, so now you see the integration, this part, it is something like the uv integral. Okay, if I let me show you, that is integration uv dx. You may know this formula, u integration v dx minus d dx, u integration v dx dx. Okay, so you know this, but for our integral, you may know, or you may have knowledge of calculus 1, that this type of integral, if you want to evaluate, it will take some time, or the solution will be linger. Okay, so if you want to avoid this type of uv integral, you may use the formula, that is e to the power x, I should write ax cos bx dx. Directly this will become e to the power ax a cos bx plus b sin bx by a square plus b square. So this formula will help you much to evaluate this type of integral directly. Okay, also you may recall another formula, e to the power x sin bx dx. This will be e to the power ax a sin bx minus b cos bx. These formulas are not much hard, you can easily memorize. Okay, but these are very important. I mentioned these three formulas by star. Okay, I should write triple star. Okay, these are very important, and throughout the part of Fourier series and transform, you will need these three formulas of integration. Okay, so remember. Now using the second formula, we can write 1 by pi, this will be e to the power x cos nx. Here a is 1, and the coefficient of e to the power e to the power ax, I mean the coefficient of x, and b will be n from cosine part. So it will be cos nx plus n sin nx by a square plus b square, I mean 1 square plus n square. Give the limit minus pi to pi. Okay, now we can write 1 by pi into 1 plus n square, as this part is constant, and we want to put the upper limit and lower limit. This will give it to the power pi cos n pi plus n sin n pi, and minus for lower limit cos minus n pi plus n sin minus n pi. Okay, and from this we will get pi into 1 plus n square, and this will give e to the power pi cos n pi plus 0. I will explain why sin n pi is 0, minus this will give cos of n pi as cos of minus theta means cos theta, and this will also give 0. Okay, so you'll have to remember, because sin n pi equals 0, as we know that is sin 0 means 0, sin pi means 0, sin 2 pi means 0. Okay, our n in the formula is an integer. From, you see, n goes from 1 to infinity, and summation variable is integer, and especially positive integer. So here n is also represents those our integer from the sign part, or n is a variable of summation. Okay, so this will gradually become 0 if we increase n. Okay, so it will be 0, 1 pi, 2 pi, 3 pi, 4 pi, something like that. Okay, and cos n pi is not 0, because we know cos 0 means 1, cos pi means minus 1, and again 2 pi means 1, so it will give you 1 and minus 1, 1 minus 1, 1 minus 1. Okay, and for this part, I mean cos n pi, we write minus 1 to the power n. Okay, so now let's finish this part. Okay, I hope you have understood. So this will give 1 by pi into 1 plus n square, and from this part you will get e to the power pi minus e to the power minus pi cos n pi. Okay, so finally we can write minus 1 to the power n e to the power pi minus e to the power minus pi by pi into 1 plus n square. This is the value of an. Now we will have to find the value of bn. Okay, so I'm turning the page. Okay, sorry for the interruption. Okay, now for bn, we write one by pi minus pi to pi f of x, that is e to the power x, sin n pi x by pi dx. So this will also give 1 by pi minus pi to pi to the power x sin nx dx. And from this, using the third formula, we will get e to the power x